so today we are going to write our article on a doubly linked list in Rust. We won't be writing the actual code today, but we will start writing the article. Oh, hopefully finish writing the article and just leave the code snippets unwritten as usual. So that's what we've been doing. This is our third data structure we're going over, or I don't know, data structure / algorithm. We started with search algorithms for linear and binary search. Then we did singly linked list last a week. Let's see, somewhere here, maybe there, maybe in published. Nope, I keep clicking the wrong thing. There we go. There's that singly linked list post. And now we're going to write about doubly linked lists, aka managing multiple references in Rust. Okay. So in the last article, we talked about what a linked list is and how to implement a singly linked list in Rust. This will be a link to that. We found out it wasn't that bad. Maybe we should say, I don't know if, nope. It wasn't that bad. It wasn't that bad. Hold on a second. I need to mute something. One hour mute. Okay. We found it wasn't that bad. And E wasn't that bad, and simply accomplished by using a box, a version, a type of smart pointer in Rust. I think that's fair. Let's see, make that code. However, doubly linked lists are a different story. Needing to manage more than one pointer in Rust. Let's see. Needing to manage multiple references. We'll say that. Multiple references is not the easiest thing to do in Rust. It's not the easiest thing to do. Let's see, did I say in Rust too many times? In the last article, we talked about what a linked list and how to implement is and how to implement a singly linked list in Rust. We found out it wasn't that bad and simply accomplished by using a box, a type of smart pointer in Rust. However, doubly linked lists are a different story. Needing to manage multiple references is not the easiest thing to do in Rust. That's fine. Okay. Needing to manage multiple references is not the easiest thing to do in Rust. Multiple references and support mutation. It's probably the correct way to say this. Needing to manage multiple references and support mutation of the underlying data is not the easiest thing to do in Rust. Yeah, I think that's better. Maybe I should say for beginners to Rust. So it's really not that hard once you know how to do it, right? For beginners to Rust. Yeah. I think that's fair. Let's just do a what is. Wait, is it a 3? I always forget if I use a heading 3 or not. Well, this isn't zoomed, so it's not helping me. I think I do use a heading 2. What is a doubly linked list? Okay. Why are we still on head? Go back. Go back to normal text. Okay. We're so good at this. What is a doubly linked list? In a singly linked list, we store our head. Yeah, I know. It's annoying. It's a terrible, terrible writing interface, but oh well. They surely don't live in Dublin. What do you mean? I don't get the joke. What is a oh, because of doubly? What is a doubly linked list? They don't live in Dublin. A Dublin linked list. Nice. I like it. In a singly linked list, we store a reference to our head node. Sorry for the pain. No, you're good. It's hilarious. All good. In a singly linked list, we store a. Oh no! What's up, stuck in for loop? Well, I guess you might still be listening to an ad, a French ad. I do need to potentially. I'm good. I do need to probably enable ads so that we can disable pre-rolls sometimes. You know, I think that's a better experience for most people. That's kind of like the consensus on Twitch, is that we all hate ads, but if we enable enough ads in the middle of the stream, you don't always get hit with a pre-roll, which is almost worse. I don't know. In a singly linked list, we store a reference to our head node and each node stores a reference to the next. Yeah. Free blog. Yeah, it's free. I don't charge for these words. Cool. Yeah. Appreciated. You agree as a turbo user. Hilarious. So you double disabled ads, Purplish, because you have a sub and you have turbo. Impressive. In a singly linked list, we store a reference to a head node, and each node stores a reference to the next node. A doubly linked list simply adds two more pointers. I mean, technically, you know, not just two for the entire list, but doubly linked list inspired me. Fair. Simply adds two more pointers. To the tail of the list, two more pointers. One for the tail of the list, and two more types of pointers. No, two more. It's not really two more pointers. Okay, we'll just keep it. We'll just say, and one in each node referencing the previous node. Okay. How can we simply show this without an actual drawing? Yeah, article writing stream today. I mean, we'll write code on Wednesday. We're figuring out how to explain a doubly linked list in a way that doesn't suck. Okay, so last time on the singly linked list, you know, I used this like pseudo code syntax to show how this works. Obviously that doesn't work here. Okay, so let's just say what if we just had like a tuple struct? I don't know. And we had head and tail for the list. Oh, I forgot that was a thing. Unicode to the rescue. It's probably not even Unicode, is it? It might even be ASCII. I don't even know. I forgot we can actually have special characters. Oh, it's literally just that. Oh my god. Why am I silly? Okay, last time I used these, I guess the equals kind of makes it seem like there's more. It's a fat arrow back and forth. Why didn't I think of that? Why am I so silly? Like, I literally just did this. It's not anything special about this arrow. I could have just put another one the other way. Oh, God. What am I doing with my life? Okay. It's okay. I think I might actually prefer this without the equals. We'll do a dash instead. Okay. Entertaining us. That's why. I just did that for you guys. We can represent this in okay. I said this represents a node and that represents a link. Okay, so right. So last time we did this, I kind of like those. The fire. Got him. I love the fire. Happens to a lot of people. I did have this that I thought was funny. Let's see. Let's see if I can do this an easy way. How about I just... Okay, I'm already on default Brave. Dear Lord. I've been tweeting too much. Oh, here we go. This is what I'm thinking of doing. You know, the fire just adds so much ambiance to our streams that I think I'm just going to continue that with interviews. And I'll just have the fire running in the background, and I think, you know, it's going to be really good. All right. Represents a node and represents a link two-way link. Obviously, two-way links don't actually make sense in code, but, you know, we'll just keep going and pretend that they do. Let's see. Yeah. So I think that's fine. Referencing the previous node. We could represent a doubly linked list in Rust-like code. Let's see if we can come up with something that's not terrible. So if we said ABC, what can we do? I guess we just have, oh yeah, we can use tuples still. We'll just have 3 elements in the tuple. Duh. Come on, Michael. Come on. Oh, that's nice. That is really nice of me. I mean, I like the fact that the other one is, let's see, did I actually get it? Fucking Twitch. Sometimes Twitch. I like that the other one is just ASCII symbols, but if we can get this to work. It's so small, though. It's so small. I don't know which one I like better. I think I'm just going to go with these. In Rust-like code. Yeah, with tuples. Let's see. So this tuple, I mean, technically a 3-element. What should we call it? Should we use the thruple? 3-element tuple. A triple. Well, triples, I guess. Okay. And then let's follow this format. What did I do? I did A and B and C none. Oh yeah, I can't do this. I'm silly. Okay, let's just do this. Let A equals node A. Maybe we just do this. Let B equals node B. Let C equals node C. Okay, so no, this kind of still sucks, but we'll just pretend this works. Let list equals A. Let me see if this makes sense. No, it still doesn't make sense, does it? Okay. You just can't. There's so many easy ways to represent a singly linked list, and representing a doubly linked list simply is not the easiest thing. It's not that hard of a concept. I think it's just trying to make this too simple. So let's just maybe construct this as a whole list. So let's just say something like, what is it? Struct node, of t is, so these pointers, this code won't actually work. Yeah. Okay. Struct node t, ref to node t, ref to node t. Okay. Yeah, this is good. Next day to node B, prev B to node A, and so on. Yeah, you could do that. I'm just gonna try this and see if I like it. Hey pizza, yeah, this is a new one. So now we're on to doubly linked list. So we published our singly linked list article. Now we're on to doubly. Yep. Okay. So let's see, struct node t, and node t, and node t. I think this is fine. So let's just create our first node. So we're gonna say let a equals node. We'll just say a, so we don't get confused with actual things. And this will be none, and this will be none. Okay. Obviously, this code won't work. Implicit optionals. Let's pretend that we could just have like a implicit optional inference real quick. Okay, so then we construct node B by then saying, oh, that is a good point. I mean, in general, of course, also, it doesn't matter. We'll just keep going. So node B ends up being this, and then we're going to take a reference to A as our prev, and then none as our next, and then C is going to be, what did I just do? What happened? Okay. A.2 equals and B, and I'm not even going to put that in there. You're just going to figure that out. Let's see equals, and Rust like pseudocode. How about that? A.2 equals and B. Yep. Let C equals node C and A. Just kidding. And B, none. Okay. And then we would say B.2 equals and C. We could construct a doubly linked list in Rust-like pseudocode as follows. That's funny to me. Okay. B.2 equals and C. And I think that this is great. So let's say and let list equals DLL head A, tail B. Okay. So obviously it's not the simplest code in the world, but I mean, doubly linked lists aren't that simple. I'm just thinking maybe I don't want to use a tuple struct for the node and I actually just want to do the whole thing. Maybe that would actually make this clearer. I don't think so. I think I'm going to leave it like it is. I think what I'm going to do is do something like this and say, maybe I want to go here and say it's val prev next. There we go. I think that's fine. What do you guys think? How do we like this? Head A, tail B. Oh, dear Lord Purplish. Well, I hope the cleanup of that physical or digital thing goes well for you. I guess technically we should do this. Head A, tail B. Okay. So, I said tail B. Tail C. It's funny. I wonder if actually what I want to do here is just make this. I think what I'm going to do is do and B here and do and C and forget about the actual assignment. Like, obviously this doesn't work. It would require mutual mutual declaration support, but I think it makes it does make like a little bit of sense, right? And it just like gets the point across. We have A none B, B A C, C B none, head A, tail C. And even though it's not as rusty, I'm just going to take off those commas because they're bothering me and leave it like that. Okay. I don't hate this. I think this is fine. Obviously, this code doesn't work. But it should demonstrate what the ultimate result of constructing a doubly linked list would look like. So this is what a doubly linked list is. I guess last time I just had a one huge section because of skill issue. No, I just didn't want to. It's just to illustrate the point. Doubly linked list would look like each node has a value, a prev, and a next. The list has a head and tail. We now have head. We now have O of 1 access to both head and tail. Okay, let's put this down here. There are several optimizations now available to us versus the singly linked list, where all we could do is traverse in a single direction. First, we now have O1 access to both head and tail for fetch, delete, and add. What did I call it in the other article? Fetch, insert, delete. Insert is good. For fetch, insert, and delete. I keep doing that. I keep hitting escape because that's what I do in VAM or Emacs. Let's see. You should add this code doesn't work. Oh, no, I read that. And O of N to iterate the list back and forth. Yeah, forward. Versus the single linked list where all we could do is traverse in a single direction. Are you saying you want me to say forward direction? I'm fine with how I said it. First, we now have O1 access to both head and tail for fetch, insert, and delete. We can also optimize traversal by we can also optimize traversal by traversing. Okay, I guess this is the same thing. We can also optimize traversal by starting at head or tail or both versus okay. We can also optimize traversal by starting at head or tail or both. When you iterate a linked list using an iterator in C++, it has a forward iterator category tag. Huh, interesting. For fetch, insert, and delete, we can also optimize traversal by starting at head or tail or both. Okay, cool. What else do we want to say about it? What other optimizations do we have? Maybe we should give some examples. Fetch, insert, and delete. We can also optimize traversal by starting at head or tail or both. Maybe we want to just put this here. Maybe some examples would be nice. Like we say, let D equals node D and C none list.tail equals D. I didn't do this right. It's nice to be clear that those are pointers. List.tail equals D. Inserting at the end of the list. Huh, that's cool. Push back. Viz pushback. Let D equals node D and C none. List.tail equals and D. I think that's a nice thing. We can also optimize traversal by starting at head or tail or both. What would that be? It would be, I guess we could just do a traversal from tail. Traversal from tail. Let n equals list.tail while n dot 1 while let sum n dot 1 equals n do stuff no, we'll just call it node. There we go. Do stuff, and then node equals n dot 1. Perfect. Pref. I think this is fine. And of course, like we could do it both at the same time, which is kind of the point. Let's see. Appending a list to appending lists, aka concat, is also O of 1. It's very, very simple. So let's say we have two lists. Let L list 1 equals yeah. So what am I trying to say? So let's just say we have two lists. Appending list 2 to the end of list 1. List 1 dot tail equals list 2 dot tail. List 2 dot head. Oh wait, let's do this in the right order. List 1 dot tail dot next equals list 2 dot head. List 1 dot tail equals list dot tail. That doesn't make sense. List 2 dot tail. Is there anything else? Oh yeah, list 2 dot head dot prev. List 2 dot head dot prev equals list 1 dot tail. Okay. List 1 dot tail dot next equals list 2 dot head. List 2 dot head dot prev equals list 1 dot tail. List 1 dot tail equals list 2 dot tail. Okay. Very, very simple there. I didn't forget anything, did I? we updated list 1's tail, like the actual node, to point to list 2's head. We updated list 2's head to point to list 1's tail. We don't have to change list 2's tail at all, except to make list 1 dot tail now be list 2 dot tail. Yeah, it looks fine. Okay, appending lists, aka concat, is also O of 1. Okay. Maybe we just do this. Maybe we just do this. Maybe we just do this. We're just going to call it in.prev. I'm actually thinking of changing my tuple struct to be next prev. It's going to be a little bit annoying, but I think it'll be clearer. Val next. This is prev. Prev next. All right. Val prev next. Val prev next. Val prev next. Val prev next. Okay. I think this is nicer. I'll just add a little bit of white space. Makes absolutely no sense that Control E puts me to the end of the code block instead of the end of this line. There's literally no editor I've ever used that would do that. Okay. Let's see. Do we like it here or there? Yeah, that's fine. DLT, node, DLL, all those look good. Okay. So then this just becomes really easy, except we have to change this now to node val prev next. List.tail equals and let node equals list.tail, while let sum n equals node, do stuff, node equals n.prev. Appending list, aka concat, is also O of 1. List.tail.next equals list2.head. List2. Okay. Is there anything else I'm missing? Split is basically the same, so I'm not going to talk about split. Is there anything else special about the doubly linked list that I'm not thinking about? Not really. Note that appending the list is inefficient for a singly list, but O1 for a doubly linked list. Okay, simple implementation. I don't think I'm going to implement split off for a doubly linked list like I did for singly, because it's not going to be that different. It's not anything that special. I think we're just going to do push front, pop front, and append. The only thing that I'm like a little bit wondering, okay. So then we get to managing multiple references. Yeah, I think that's the point. These operations conceptually are all very simple. All right, so then we get to managing multiple references. All of that pseudocode is great, but it's not valid Rust. We'd have lifetime issues, borrowing issues, and borrowing issues, and wouldn't be able to mutate anything. Lifetime issues, borrowing issues, and wouldn't be able to mutate anything. There are... What we need is the ability to manage multiple references in a safe way. Multiple references, and to mutate the underlying data in a safe way. Rust provides two ways of doing this in the stud lib. In the stud lib, arc mutex, arc and mutex are used when how do I want to say this? Arc mutex t. No, what is this? What is this terrible thing you just did to me? Okay, good. Arc mutex t for code. Okay, for arc mutex t, arc mutex t, which is thread safe, RC ref cell t, which is not thread safe. Okay, not bad. Rust provides two ways of doing this in the stdlib, arc mutex t, which is thread safe, and rc resale t, which is not thread safe. I actually can't remember. Really, why do you do this to me? Why do you literally hide? Why are you hiding the freaking bar? Oh my god. Why would you ever do that to me? Why would you ever think, you know what? He probably doesn't want those editing tools anymore. I don't get it. It's fine. Whatever. Which is not thread safe. Okay, I can't remember if ref cell is capitalized in the middle or not. Let's see. Docs, not reference. No, where's my stdlib docs? Why don't I have those up? You know what? We have a tool for this, don't we? It's called Poly. There we go. Ref cell. Okay. C is capitalized in ref cell. I just couldn't remember. I figured it was. Which is not thread safe. Both arc and RC are reference counting pointers. Essentially, they keep track of how many references have been created, of how many, I guess we could say reference there are. Reference have been created. Is that fair? They keep track of how many reference have been created. To have been created. Yeah, I think this is fine. Okay, so let's do this. And go, actually, I'm just going to make these links. Let's make these links to RC and ARC. It's possibly the sync docs have good things here. I guess not. Okay, it's fine. I was hoping they would have, like, I guess that makes sense because RC is not in sync. Since it's not sync, how about that? But I thought they'd have like a little thing about when to use ARC versus RC, but maybe it's in the RC docs. Ah, here we go. Thread safety. Okay. Let's see if there's a let's see which segment is better. Okay, they don't even talk about it in the RC docs. So that's the right segment. Stud RC, and this is here. Okay. Not Emacs, unfortunately. We're writing in this disaster of a product. Yep. Maybe it's just because I'm zoomed out. Let's try giving them, zoomed in. I'll try giving them the benefit of the doubt. I guess it is. I guess it's the zoom. The zoom is screwing up with their little system here. I guess we'll try that for a while. And maybe it's my fault and not their fault. I still wish that it worked, but that's okay. Reference have been created. Okay. And do the sync docs or the RC? Oh, that's what I was thinking of. Maybe the RC module docs. Here we go. This might be good. Yeah. Okay, that's fine. I think it's the sync docs that could be worthwhile. No, it's just what I actually found here. It's this. Okay. I'm just going to say that those docs are worth a read. Hey, Tapas. What's up? Thanks for the follow. Essentially, they keep track of how many references have been created and won't allow dropping created to ensure that the underlying data is not dropped until all references have what's the right word? DSA and Rust, sign me up. Cool. Yeah. That's what we're all about, man. So we've done search algorithms, and we did a singly linked list, and this week we're doing a doubly linked list. The format is essentially I write an article about it, and then I write the code for it. So I haven't actually written the code for this, and I won't today, but I will on Wednesday. So that's the plan. Welcome. Yeah, I didn't know Rust very well when I started. Well, this is a new series. Oh no. Did I get my numbers mixed up again? I thought I was on UTC -4 right now. I thought I was on UTC -4. Let's see. Current time UTC 6:12. I'm on UTC -4. Okay. And let's see if I did the math right. 1300 plus 4 is 1700. Yes. Okay, we're good. You're 2 hours away right now. I just assumed I did my time math wrong because that's very, very normal for me. Daylight savings time really screws it up. I can never remember if it's 4 or 5. Both ARC and RC are reference counting pointers. Essentially, they keep track of how many references have been created to ensure that the underlying data is not dropped until all references have what's a good word for this? I guess we could say until all reference. Yeah. Have been? Sure. Good enough. Aw. Okay. Until all references have been. Yeah, that's fine. Same, apparently. Yeah. Hey, Alice. Thanks for dropping in, though. Okay. Essentially, they keep track of how many references have been created to ensure that the underlying data is not dropped until all references have been. Yeah, I think that's good. Maybe I'll just keep saying references. I think that's fine. But ARC and RC don't allow for a mutation of the underlying data by themselves. That's why they must be used with the corresponding, I don't know, what is a good generic word I could use for mutex and refcell? Refcell. Mutable memory location with dynamically checked borrow rules. Okay, module level documentation for more. Shareable mutable containers. Rust memory safety is based on this rule. Given an object T, it is only possible to have one of the following. Having several immutable references to the object. Well, so shareable mutable containers exist to permit mutability in a controlled manner, even in the presence of aliasing. Cell, ref cell, and one cell allow doing this in a single-threaded way. They do not implement sync. If you need to do aliasing and mutation among multiple threads, mutex, RW lock, once lock, or atomic types are the correct data structures to do so. Cool. Yep. But ARC and RC don't allow for mutation of the underlying data by themselves. Mutating shared references is one of the disallowing mutating of shared references is one of the points of using Rust in general. I think that's a fair statement. Maybe that doesn't need to be parenthetical. In general. That's why they must be used with the corresponding, let's see. I was just there and then I got distracted. Shareable mutable container. Is mutex in the cell? No, it's in sync. Okay. A mutual exclusion primitive useful for protecting shared data. This mutex will block threads waiting for the log. Each mutex has a type parameter. The thread panics while holding the mutex. Sure. I think a mutex still, though, I think it would be still fair to call it a shareable mutable container. It's just an atomic one. Okay. Disallowing mutating of shared references is one of the points of using Rust in general. That's why they must be used with the corresponding type with a type of shared mutable container. And for this, I'm going to link to the cell docs because I think they're actually pretty good. Worth reading. Okay. With a type of shared mutable container. Hey, Hans. What about triply linked lists? We could do that. So we choose a what do we choose? Like a step number. So in your linked list constructor, you're actually going to pass in a number of steps that you want, and whether you want that to be forward or backwards. Well, I mean, I think it would be forward, right? We'd have to do a quadraly linked list if you wanted them to be backward based on that step number 2. So, each node would go to the next 5th node. Why would you do that? I don't know, but I'm sure it would be fun. Hey, El Cravo, what's up? That's why they must be used with a type of shared mutable container. Oh yeah, I'm terrible at thinking of project ideas. Really, really bad at it. I think one of the main things in my opinion is don't let the fact my one piece of advice is to not let the fact that other people have done it to dissuade you from doing it yourself. As long as you have chosen a sufficiently interesting technology, then it can be fun. How many times have people implemented these data structures that I'm implementing? So many times. How many times have they implemented them in Rust? Not a hell of a lot. They've been done as well, but and you can do that. You can do that with Zig. You can do that with enter your language here. You can write a compiler. I mean, it just depends on what you're interested in, right? That's just an example. Disallowing mutating of shared references is one of the points of using Rust in general. That's why they must be used with a type of shared mutable container. Okay, in this case, mutex, which is thread safe, or refcell, which is not thread safe. I'm just going to repeat that because I think it's important. Yeah, it's been a while, Hans. Last time I saw a 3x linked list was for simulating DOM when having to walk the tree up and down for querying. That makes sense. I mean, if there was like a sense of hierarchy or ordering, I suppose it could be helpful, right? Was the 3x linked list literally what I said? Like it was like a certain step forward? I just made that up off the top of my head. but that's like the only thing I could think of doing, really. I mean, like, what else would you do? But yeah. That's why, or I guess it could be like to a certain thing. Essentially for selecting elements nodes. I guess that's true. Like, it's weird. It is kind of weird that they put that in a linked list instead of a tree. Like some sort of tree. But I probably just don't understand exactly what they were actually trying to accomplish. I guess I could see it if you were like, okay, now we're going to put a reference to this next element here after we've done, I don't know. It's fine. That's why they must be used with a type of shared mutable container, in this case mutex or refcell, which is not thread safe. Okay. Can I make link things code too? No, it just deleted my link. Okay. That's what I figured. So let's just link to mutex docs. Okay, these are, no, those are RC docs. Let's do mutex and refcell. I do need to learn more about the, like, all the other cell types, because I don't know that much about them. TBH. Refcell. Mutex. I just love documentation links. I don't know if, does anyone else use those in articles? I use them all the time. I love documentation links. All I can do is post the project. The rest is up to you to figure out. Thanks, Hans. I appreciate that. Yeah, that is true. That is very true, Doro. That is exactly what it is. Okay. Maybe I'll look at this later. We'll see. We'll see if we get there. Okay. That's why they must be used with a type of shared mutable container, in this case mutex, which is thread safe, or refcell, which is not thread safe. How about it? Okay, I already set it up here. Those documentation links are great reading. Okay. I think this is fine. And I think it explains it well enough. Maybe there's a nice... We could go to the Rust book, I guess, if people want more. Rust book. Rust book. Arc. Fearless concurrency. Shared state concurrency. Okay, sure. Okay, let's try, oh, here we go. Refcell, the reference counted smart pointer. Perfect. We'll link to this. I recommend the book, the book's chapter on RC, I'll say section on RC for further understanding. Okay. We'll go here. See, no, it did. They deleted my freaking... Wait, where is it? Where's my Where's my editing tools? Why do they love doing that to me? God damn it. Freaking Substack. All right. Okay. I'm not going to say simple this time. Here's the code. Here's the implementation of a doubly linked list in Rust with pop front, push front, pop back, push back, I wanted to do those, and I wanted to do and append methods. I chose to use arc mutex but the implementation with RC refcell is nearly identical. The downside of using mutex of using arc is arc and mutex is the increased overhead of how did the doc say it? They said it better. I think it was in the cell docs, not cell docs, in the arc docs, probably. Atomic operations are more expensive than ordinary memory access. Yeah, okay. I chose to use arc. Okay. The downside of using arc is the increased overhead of ensuring atomic operations. Okay. I chose to use arc mutex, but the implementation with RC refcell is nearly identical. I think this is good. Let's see. I link the doc links because I'm lazy. That's fair too. That's so funny, Hans. I do that with so many things. I can't remember important things, but super abstract things or things that are very much on the side of usefulness, I'll remember. Hey Brev, what's up? You only have 7 tabs open, not bad. Well, the mess couldn't have been too bad, Purplish. I mean, you're already back, right? I chose to use arc mutex, but the implementation with RC refcell is nearly identical. All right, and now we get to do a whole lot of these. This is so fun. Such good content right here. Oh my god, look at this. Imagine not just supporting a keyboard-centered way of being able to mark these as code, as little monospaced font code things. We'll do arc there. And we have some more. I think this looks fine. Is nearly identical. Okay. insert doubly linked list here. Good times. Yeah, exactly. No, that's it. It's exactly why I chose to just use Substack, because I knew like it would be so tempting, right? Oh, let me just implement my own blog real quick. I didn't want to do that. I should have chosen something that actually just supported Markdown though, instead of some stupid proprietary thing, but oh well. Okay. Summary. Let's go summary. All right. We're going to copy this. Let's insert a divider. And what was my summary like before? Okay, the source code with tests is available on GitHub. That should still be true. The link should change a little bit. Let's just see. I guess we'll call it doubly linked this time. Doubly linked list. I guess the only other thing I wanted to do is read. I actually wanted to read the Rust stdlib source code for a linked list to see like how they implement it. But I guess we should at least put a link to their linked list docs. Have I ever told you how your blog works? No. Real quick, 4 hours for one CSS class, right? Exactly. Yeah, plus I'd have to do front end. Ugh. By the way, I did mention you in my latest article. Forgot to ask, but I guess it's fine. Yeah, man, of course. Of course, Priv. All good. Struct stud collections, linked list. It's a Polaris script that builds a bunch of stuff with Pandoc and embeds Flora for templating. Oh my god. Can I introduce you to Obsidian? Like because they have a publish thing and all that kind of thing. Wow, Nightshade, you're so early. You're so early, Nightshade. Unbelievable. Did Prime just end or something? Let's see. Stud collections, linked list. Nope, wrong screen. The prodigal son returns, right? Not what I was supposed to do. Of course, the Rust standard library, I'll just say stdlib, that's what I say, also has a linked list. A doubly linked list. The Rust stdlib also has a doubly linked list. So there's unlikely a need to implement your own for a Rust project. The source code with tests is available on GitHub. I don't know if I even really need to say that. It's pretty obvious. It's pretty obvious, but that's okay. Yeah. Oh yeah, next post. In the next post, we'll demonstrate how to use our, I might just do this in this post, how to use our doubly linked list to create a FIFO first in, no, not a FIFO, a last in, first out queue. A LIFO. No, I do mean first in, first out. Dang it. I do mean first in, first out. I'm getting confused because I'm trying to finish this fast. A FIFO queue. You're the prodigal son, Nightshade. How many boxed ins and unsafes have we done? Zero. I would never write go on stream. Okay, I might eat those words someday. I don't know if that's true, but I really doubt. The source code test is available on... I mean, this is so simply easy that I don't even know if it's going to be a new post, but we'll just see what happens. Okay, we'll see what happens. But I guess it's good. I guess it's good to show like you create a little queue. I guess it's worth a post. I don't know. We'll see what happens. Yeah, exactly. Exactly. You misspelled Idris, yeah. That would be fun. Now you're talking. Now you're talking. Okay. Let's see. I recommend the book. Okay, so we did all this. What do I want to summarize? What do I want to summarize here? Okay. Implementing, this is what I want to say. Implementing a doubly linked list is a great way to learn how to deal with managing multiple references, managing multiple mutable references in Rust. Okay. There are far more use cases for a doubly linked list than a singly linked list. The efficiency advantage of having both access to both sides of the list. There is a notable efficiency advantage of having access to both sides of the list. I didn't talk about use cases. I didn't talk about them, but I'm just gonna say that there are without actually listing any of them. There's a notable efficiency advantage of having access to both sides of the list. The source code with tests I think this is good enough. What else did I talk about? I guess I need to read it. Maybe I don't know how to summarize it because I didn't even read it yet. What was that last song? Oh, you know how hard it is to look in your queue and see what was played last on Spotify? I don't know if it's hard. I don't know. Recently played. Is it the very last one? I'm guessing it's the one at the top. Milano by Russian Circles. Do 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 do. Here you go. You can see if this is what you're looking for. Okay, let's read this real quick. See if we need to add anything to the summary. And see if I can do anything else for a few minutes. Okay. Rust DSA, doubly linked list. Managing multiple references in Rust. In the last article, we talked about what a linked list is and how to implement a singly linked list from Rust. We found out that it wasn't that bad and simply accomplished by using a box, a type of smart pointer in Rust. However, doubly linked lists are a different story. Needing to manage multiple references and support mutation of the underlying data is not the easiest thing to do for beginners, for noobs, to Rust. What is a doubly linked list? In a singly linked list, we store a reference to our head node, and each node stores a reference to the next node. No, I was up there. Why'd you do this to me? All right. A doubly linked list simply adds two more pointers, one for the tail of the list, and one in each node referencing the previous node. So by two more pointers, I actually mean a fuck ton more pointers. Okay, little example. We could construct a doubly linked list in Rust-like pseudocode as follows. We got a head and a tail. We have a val prev next. 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 We have a head and a tail. Obviously, this code doesn't work. That's why we call it pseudocode, you stupid piece of... All right. But it should demonstrate what the ultimate result of constructing a doubly linked list would look like. Each node has a value, a prev, and a next. The list has a head and tail. There are several optimizations now available to us versus the singly linked list. First, we now have O1 access to both head and tail for fetch, insert, and delete. We can also optimize traversal by starting at head or tail, or both. Appending lists, aka concat, is also O of 1. These options conceptually are all very simple. Enter Rust, making what's conceptually simple extremely difficult. Managing multiple references. All the pseudocode is great, but it's not valid Rust. We'd have lifetime issues, borrowing issues, and wouldn't be able to mutate anything. Why? Because we'd have multiple references, and you can't have a mutable reference with another reference at the same time. What we need is the ability to manage multiple references and to mutate the underlying data in a safe way. Rust provides two ways of doing this in the stdlib. arcmutex-t, which is thread safe. Oh no, I went too far. rc-refsail-t, which is not thread safe. Both arc and rc are reference counting pointers. Essentially, they keep track of how many references have been created to ensure that the underlying data is not dropped until all references have been. But arc and rc don't allow for mutation of the underlying data by themselves. I keep saying underlying data a lot. Oh, this is where it would actually referent would be right, but it's fine. We'll just say underlying data. Disallowing mutating of shared references is one of the points of using Rust in general. That's why they must be used with a type of shared mutable container. In this case, mutex, which is thread safe, or refcell, which is not thread safe. The downside of using arc is the increased overhead of ensuring operations. Atomic operations, I forgot that word. I recommend the book section on RC for further understanding. Here's the implementation of doubly linked list in Rust with pop front, push front, pop back. Okay, we're not going to read all that. Okay, implementing a doubly linked list is a great way to learn how to deal with managing multiple mutable references in Rust. There are far more use cases for a doubly linked list than a singly linked list. There is a notable efficiency advantage of having access to both sides of the list. The source code with tests is available on GitHub. The Rust.lib also has a doubly linked list, so there's unlikely a need to implement your own for a Rust project. In the next post, we'll demonstrate how to use our doubly linked list to create a FIFO queue. Because we're cool. To catch live coding of data structures and algorithms in Rust, follow MetaMe on Twitch, watch VODs on YouTube, and get updates, bad takes on Zitter. All right, good enough for me. So yeah, Wednesday we will write this code by YouTube.